Welcome to SmokeGuard's AIA Continuing Education series. Today's AIA course is titled Passive Fire and Smoke Protection for Hospitals. This course has been approved for one learning unit for health, safety, and welfare with the American Institute of Architects. SmokeGuard is part of the Engineered Building Solutions Group, a segment of CSW Industrials. The EBS Group unites Balco, Metacock, SmokeGuard, and Greco. These four leading brands provide innovative, safety-focused solutions for architects, building owners, engineers, and contractors with a shared commitment to life safety by design. SmokeGuard offers flexible, visually appealing fire and smoke protection systems designed to cover everything from small openings to large atrium spaces. SmokeGuard offers a full line of elevator smoke containment systems, including vertical, horizontal, and perimeter fire and smoke curtains, as well as shutter and static curtain solutions. SmokeGuard is a registered provider with the American Institute of Architects CES program. This course is approved and in compliance with AIA. This program is not intended to promote any specific construction material or method of use. At the completion of this video course, you will need to take our 10-question test and get 70% correct to receive your AIA Certificate of Completion. You will receive your certificate via email. If you are an AIA member and you provided your member number, we will report your course completion to AIA for credit. Please allow for up to 10 business days to report credit to AIA. This presentation is copyrighted by SmokeGuard. Any reproduction, distribution, display, or use is prohibited without written permission. In this course, you'll learn how smoke moves through hospital environments and what design strategies are most effective for containing it. You'll explore the code requirements for smoke protection, especially around critical areas like elevators, and gain insights into architectural options that support safety and compliance. This course also highlights common mistakes to avoid and demonstrates how passive systems can improve wayfinding and support smooth movement for both patients and staff. This presentation was pre-recorded by David Bauer. David is the Architectural Director for SmokeGuard. With that, let's turn it over to David.
So as we go through this, you're going to notice that we have some little legends that may pop up on the screen. And on the lower left, there is that legend for what type of wall we're talking about. This will show up in building sections. This will show up in building plans. And then also, if you see something that's underlined, it is hyperlinked too. So if you get the PDF after this, then you'll have that. So we're going to talk about primarily vertical openings. Quick thing is when we're talking about vertical openings in the broad sense, vertical openings is defined in section 712 of the building code, 712.1. There are really four of them that are occupiable, that are really the things that we really want to look at, the ones that really drive building design. We're not talking about slab penetrations and things like that. We're talking about occupiable spaces. Well, two of the four that are in there are gone. You just can't do them in I2 occupancies. So that leaves us with pretty much any vertical opening in a hospital is going to be defined as a shaft enclosure or as an atrium. Now, that's not to say that the other vertical openings aren't there also, things like mezzanines and penetrations and things like that. But the occupiable spaces, the ones that really build drama in a building, the ones that from a design standpoint we really key on to make it a quality space is really shaft enclosures and atriums. There are no two-story openings in I2 occupancies. There are no unenclosed exit access stairways in I2 occupancies. And then over on the life safety side, now, as we know, we're always going to reference the 2012 NFPA 101 because that is the one that's applied by CMS. So if there's Medicare money involved, it's a 2012 NFPA 101 and not a more current version. So we'll reference that one in particular. But communicating spaces that we see all the time in business occupancies and other type buildings that are subject to NFPA 101 are not permitted in healthcare at all. So we're down to three there. And these roughly translate into the two that we already have in the IBC. And as you probably know, that these both parallel each other to a degree, but not 100%. So that is actually what makes it tricky. So first, let's talk about a couple things. We're going to talk about rated walls in buildings, just what they are, and just so that we know what we're talking about in terms of the base information when we go in there. We're talking about 5 different types of rated walls in any building. We use firewalls. We know what those are, fire barriers, fire partitions, and you can read them there. But the first 4 of these are fire rated, and the last 3 of these are smoke rated. And it doesn't make a whole lot of difference with regard to the wall structure. Obviously, fire walls are constructed differently, but the fire barriers, fire partitions, and smoke barriers, you can use the exact same UL assembly out of the Big Orange Book, or what used to be the Orange Book, and the exact same assembly to construct any one of those three walls. But they have different designations because their applications are different. That's one thing. And then because their applications are different, they also have differences in the openings that are permitted. So it's important to note where the smoke rated walls are. But if we look at what the openings are, we're limited severely in firewalls and fire barriers. We can only have 25% or less of the overall wall length being open. That's windows, doors, whatever you have, any kind of an opening in there. And then when you step into fire partitions or smoke barriers, there's no limit. And of course, smoke partitions, which we're going to talk about a lot in hospitals, those have no limit either. Of course, those aren't fire rated either, but we do have the smoke rating requirement. So probably the biggest single item that affects what we're talking about with respect to vertical openings, smoke movement in I2 occupancy is probably corridor wall construction. It might not seem it at first, but if you think about the preponderance of corridors running all over the place in hospitals, we've all been lost in hospitals, I'm sure. Follow the blue line to the 7th elevator you come to, and you walk 7.5 miles before you get to where you're going. Well, that's all the time in hospitals, particularly as a visitor, which normally we're going to be. If we're design professionals, we know the facility pretty well, I would think. And if we work there, we know it very well. But more often than not, we're going to be a visitor, or most people walking to that hospital are visitors. So there are corridors all over the place connecting everything. All the corridor walls that have to be accessed, that can be accessed by patients, are required to be constructed with smoke partitions. So that's why it's so important that we understand those wall types. Smoke partitions are all over the place. Now, if you're working on a project in California, those smoke partitions just became fire partitions. Just remember, the California Building Code is somewhat different, and they will require and prohibit things that are not necessarily required or prohibited in the IBC. But outside of the state of California, we're constructing walls as smoke partitions. So what does that mean for us? Well, the actual opening requirement is this semi-enigmatic statement that we have to limit the transfer of smoke and provide positive latching. Well, the positive latching, that we understand, but limit the transfer of smoke is a little bit vague. No, it's significantly vague. I have never understood how you quantify limiting the transfer of smoke. A screen door will limit the transfer of smoke. So that's clearly not what they intend. So in talking to multiple AHJs and fire protection engineers, to a person, they all say that is an S label on a door or tested to UL 1784. Now we're going to talk about what that means. And there's an equivalency between UL 1784 testing and an S label. So it's probably more correct or better for us to put an S label on the drawings, but UL 1784 is the actual standard that's applied in order to achieve the S label. Okay, why do fabric curtains? Why not just do steel? We've been doing steel forever. I don't know when I detailed my first steel closure into a building, but it's probably 30 years ago. But this project I worked on in a hospital probably nearly 20 years ago. And it's a corridor, and this is the opening into a cafeteria, pretty much in every hospital. That corridor is constructed as smoke partitions. So that opening right there is required to limit the transfer of smoke, whatever that means. In my mind, I thought, well, if I'm going to stand behind something, it's not going to be something that, I thought kind of sort of limited it. No, I put in something that had an S label. I put in a coiling steel door, had a 22-inch housing jammed up in the ceiling of a hospital, which, as you know, and if you work on hospitals, everything else is up in there too. It wasn't too big a deal back then, only because I knew that was going in. I knew I'd have to put a big housing, which is all we had at the time, into a very crowded ceiling space, which was what we know you're going to get in a hospital. But it was known that this is what we have to go through. So it wasn't particularly difficult. It was difficult. We had to go through all the steps, but it wasn't anything that took me by surprise. Today, this is why we use fabric curtains. We will get rid of that steel. We're looking for a smoke rated system. Instead of that 22-inch housing, I'm putting in a 6-inch housing. I'm not ever having to reinforce anything. It's simple, it's small, it's diminutive, it's non-obtrusive. It doesn't get into rerouting O2 lines and nitrogen lines and everything else that's going on up in there. It's just much, much simpler. So that's one of the reasons why we lean towards that. Another universal fact with hospitals are smoke compartments. There are a lot of newer requirements in the newer versions of the code that give you a little bit of a leniency with regard to the size of smoke compartments. We've always gone by 22,500 square feet, but you can exceed that in the IBC. However, in 2012 NFPA 101, you're stuck with 22,500 square feet. So effectively, in nearly every hospital we're going to work on, it's going to be 22,500 square feet. So, but look at that in the newer versions of the code, there is some leniency if for whatever reason, and I can't really imagine how, but if you're looking at an I2 occupancy that isn't required to be subject to the scrutiny of CMS. Multiple use fire assemblies. If you consider this corridor here, let's not even call it a corridor, let's call it a space that's bound by blue walls. And then you look at that space that's bound by red walls. What is the fire and smoke rating requirement on that center portion that's shared by both, the one inside the dash box? You have to provide a smoke rating because of the blue area. You have to provide a 2-hour fire rating because of the red area. If you apply the phrase that the more restrictive of the two governs, you might say, well, that means 2-hour fire rating. Well, that would be wrong. That section of wall is required to be compliant with the requirements for a 2-hour fire rated wall and a smoke rated wall. Now, if that's a very tiny room and you have a door in it, that door will have to comply with both of those as well. If it's a shaft, you probably don't have a door, in which case you don't have to do anything. You just have that 2-hour requirement for the shaft, which is already going to cover you on the smoke rating because you have no penetrations in it. But once you start poking holes in it, now we have to take that into consideration. This is something important to keep in mind as we go through this. Here is a hospital I worked on years ago. It was a 5-story brand new out of the ground hospital. And it was, I was fortunate that I got to work on this, that I got to lead this design team because we do so many renovations in hospitals. We don't usually get opportunities to do a brand new hospital. I did get that opportunity. So this is a 5-story building. It's an I2 occupancy. And we're going to look at in the future, in a couple slides down the road, we're going to look at what are the specific requirements. But I will jump to the punchline on this one. I had omitted smoke protection at level of exit discharge, which is right on line. It's not exactly a flat site, but pretty much flat site. But that's right underneath that canopy and back. I had omitted smoke protection because the section of the code that I was reading said I could. Here's the trick with multiple use fire assemblies. If there's more than one requirement placed on a building component, you have to comply with all of those requirements. I had only complied with one. Now, fortunately, I caught it. Let me show you what that omission was. This is the level of exit discharge, and these are the elevators opening into the corridor on the level of exit discharge. This is kind of a sneak preview into the details that we're going to look at in a moment. But if you are permitted in the elevator and conveying systems section of the code, if you are permitted to exclude the level of exit discharge from having smoke protection, what's wrong with those elevators opening right into the corridor? Well, with regard to that section of the code, there's nothing wrong with that. My problem on this project was that only late in the design process did I realize, wait a second, I have another totally independent requirement placed on me in hospitals that I have to comply with. And that is that corridor construction is required to be that required for a smoke partition. As far as the wall itself goes, that's pretty easy. But as far as the penetrations through the wall goes, that's significantly more difficult. Remember, it has to limit the transfer of smoke. And if you've ever been around an elevator door and seen the way smoke pours through that in any kind of a test, you'll realize that in most definitions is not going to limit the transfer of smoke. Most AHJs, most fire protection engineers and architects that are particularly knowledgeable about this stuff, they're going to say that, no, I want an S label there. So I realized I needed smoke protection at these doors, and I didn't have it. So I put that side acting horizontal system up above that you see in the ceiling there when I was about 90% complete with the construction documents. It was a last minute save. It wasn't wrong. It was a correct solution. It was not a particularly elegant solution, however. Here's some things you ever wonder why we put this sign outside elevators? If when the elevator goes into phase 1 emergency recall, and if that is triggered by the general alarm of the building, why would you ever have to have this? The second the building goes into alarm, the elevators go into their phase 1 emergency recall mode. In other words, they go to the level of exit discharge and the doors lock open. If that's the case, this is the most pointless sign in the world. But it's not the most pointless sign because that's not what happens. Building goes into general alarm. Actually, consider hospitals. You have elevators all over the place. Any given hospital does not have one bank of elevators. They've got 7 of them. They've got 14 of them. They have 9 of them, but they're scattered all over the place. So any one of those elevators, in terms of moving from normal operating mode into phase 1 emergency recall, is entirely independent of the general alarm of the building. So the building goes into alarm and you're standing in front of an elevator, That elevator is normally operating until smoke gets to the smoke detector that's right above your head. When it gets there, that smoke detector associated specifically with that elevator shaft, that and only that will put the elevator into phase one emergency recall mode. It's kind of important to note for some future solutions that we're going to look at here. Where's that information? Because I've never seen that in the building code. Well, it's not in the building code, or not directly in the building code, but the building code refers to another document called the elevator code. It is in the elevator code. Now, if you think that we don't have to comply with that, this is the elevator guys, for the most part, you're correct. The elevator subcontractor is going to take care of most of that. If you have an elevator consultant, he'll look at that. He'll know that. Generally speaking, we don't have to look at that, but there are a couple things in there that we do have to be aware of. And if we're not aware of, they can be kind of a gotcha. And I'll get back to that in a moment. But recall the coordination, however, between the status of recall of the elevators prescribed in the elevator code and having to put this sign out there. So 3 operating modes. You've got normal operating mode, phase 1 emergency recall, and phase 2 emergency recall. The change from phase 1 to phase 2, just when the fire department comes in, take their key and they turn it, it's now their elevator. So when, as normal occupants of a building, we will operate an elevator in automatic mode or normal operating mode. In phase 1 emergency recall, it works in a similar way, except that it's in what we might call analogously a manual mode. So the firefighters will take that elevator to the floor that they want, and they will do whatever they want with it in a different manner. So they have greater control over it than we normally would. The initiating device for this, as we mentioned, is the smoke detector outside the elevator, top of the elevator shaft, and in the machine room, if you have a machine room. And here's something that's in the elevator code and not in the building code, but it is something that you and I as architects might specify. We'll get to that in a moment, but that is in the elevator code. It's important to remember that. So just make a mental note of that. We're going to come back to that. So in chapter 30, in the elevators and conveying systems section of the code, or chapter of the code, I should say, it says that in hospitals, if you have a hospital that connects floors more than 3 stories, so 4 or greater, smoke protection is required at the elevator door. And it's not required at the level of exit discharge. That's an exception for you. That was the exception that I read. And that's great, except if you have an elevator that opens onto a corridor at the level of exit discharge, there's a whole separate requirement that still makes you do that. This is not a get out of jail free card. That exception at the level of exit discharge is applicable only to this section within which it resides. It's not a universal exception that you can apply to other sections of the code. It's very important to note that. So let's look at some of the options that are available to you. That was 306.2. And we're going to jump through option number 1 because that is for unsprinklered buildings, and we don't do that in hospitals. So let's not worry about it. But option number 2 is you can put in smoke-rated elevator lobbies in a sprinklered building, which all our hospitals will be. So we can do a configuration like this. These are required to be enclosed with smoke partitions. Now remember our wall types, smoke partitions are smoke rated, not fire rated. And what is the smoke rating in an opening of a smoke partition? It's required to limit the transfer of smoke, which is translated 99.9% of the time to mean an S label. So why am I writing UL 1784 on there? Well, we mentioned this earlier. UL 1784 is the standard applied such that we can achieve an S label on a door. Now, there are 2 different types of S labels. And if you look at a label on the door itself, on the spine of a door, you won't see a difference. It only says little S in a square. But it comes in 2 varieties, and it's very important to note these 2. That can either be tested without an artificial bottom seal, which makes you scratch your head just a little bit because it brings to mind images of actually putting an artificial bottom seal on doors and then testing it. And that's exactly what they do. So there's testing with an artificial bottom seal and without an artificial bottom seal. And as brutal and ridiculous as it sounds, testing with an artificial bottom seal is duct taping the threshold of a door before you test it. And that's exactly what they do. That's fine in normal doors. Typically, smoke comes from above. It's not a major deal. We undercut doors. We have ADA requirements we have to worry about. We have undercuts for HVAC purposes. We undercut doors for a number of reasons. And so we normally accept that as smoke coming from the top down to the bottom. But when you're working around elevators, that's not the case. When you build an elevator lobby like this, that is not applicable yet. We're going to get to that in a minute, but it's important to note that this door here that you see at the entry of this elevator lobby can be tested with an artificial bottom seal. So it is the more lenient of the two. Hospitals all have corridors constructed as smoke partitions. So if we are opening into that smoke partition, that opening of the smoke partition has to be an S label also. Well, we've already covered that because we have to do that for the lobby too. So this is one of those not incredibly rare situations where one device, one solution fits two different requirements with no extra stuff. So that UL 1784 door is an applicable opening for a smoke partition, and it's an applicable opening for the opening into an elevator lobby, which is also a smoke partition. Now, what if you have something like this? Now, you might think that you don't see this too often in a hospital, and you might, in your mind, conjure up a little 3-story hotel at the interchange of the interstate, Route 1. And yes, it is common there for sure, but it's more common than you think in hospitals. So I took this picture in a hospital about a year ago. And what's wrong with this picture? So as we're standing here, let's think about the things that we do know. The elevator lobby is required to be constructed with walls that conform with the requirements for a smoke partition. The doors in those smoke partitions, so the smoke partition is very close to us, about 8 feet away in this picture, and then about 22, 24, 26 feet away in this picture. Those are both smoke partitions. We have openings in those smoke partitions. What does that have to comply with? It has to limit the transfer of smoke, because those are smoke partitions. That's just what we have to do. So what's wrong with the picture other than that? If we look in the background, we're going to see an exit sign right in the far, beyond the elevator lobby. So from this position, we know we have to egress through the elevator lobby. This is where lobbies get to be problematic, particularly in hospitals. So we go through that near set of doors and they both swing in the direction of egress travel. We're good. Nothing to worry about until we get to the next doors, 16 feet away. Now those go against the direction of egress travel. Now, I can't tell you that in this building there's an exit sign behind us and you have to go both directions, but I will tell you that you do have to go through those far doors in the direction of egress travel, and this configuration does not permit that. The point being that if we put doors in that are there for a purpose other than egress, and these are not necessary for egress, but they have to comply with requirements for egress, you have to be careful about those requirements. So these doors would have to both swing in the direction of egress travel. Seems like a subtle point, but this is very, very easy to miss. And we see it missed all the time. All right, I'll go through this pretty quickly, but did you know that door labels can be on top of the doors? Well, my father lived in a senior living facility, and it would annoy me to no end that when I went to his place, had to have also smoke rated, fire rated doors, 20-minute fire rated S label doors, that there was no rating on his doors. This is a generic application, but a fire protection engineer friend of mine told me, no, the label can be on top of the door. It doesn't have to be on the spine. And I scratched my head and I was confused by all that. And I thought, really? So next time I went to my father's house or father's apartment, I found this. Okay, great. The label is technically on top of the door. So there is a label. Its validity is 0. There is no listing on this door because they obscured the label. Also, the only door on planet Earth in which the painter actually painted the top. So let's look at this, okay, in hospitals. So what are we doing? We can do additional doors. We talked about lobbies. Now we're going to talk about additional doors. What is an additional door? It's really as simple as you think it might be. It's putting another door in front of the elevator door. That seems a little bit odd and maybe cumbersome, but it is permissible. Now, up until the 2024 edition of the IBC, there were a lot of very good solutions built into this section. The best solutions now have been pulled out of this section and given their own section, and we'll cover that in a moment. But in 2021 and earlier, they were part of this section. So in this, we're just going to talk about side hinge doors. So what's the requirement in front of an elevator? If that elevator opens into either one of two reasons, either opens into a smoke rated corridor or opens from a shaft that connects 4 stories in an I2 occupancy or more. So this is the possible solution. This is, as disturbing as it may be, a relatively code compliant solution with some exceptions. This is a great picture. It's a hotel, not a hospital, but it's a great picture of something that's easy for an architect to miss and have inadvertently not checked the box in the elevator code. We don't read the elevator code normally, but we are required for anything in front of an elevator door to provide visibility through it. So if we put a side hinge door in front of an elevator, we have to have visibility through that door. You can scour the IBC all day long, you're not going to find it there. Some states have adopted it into their codes, or one state that I'm aware of. But it is in the elevator code, and the elevator code is mentioned in the building code. And even if it was not, the elevator inspector is still enforcing compliance with the elevator code. So you can get a building inspector comes out here and looks at that door and says, you're good, and walks away because he doesn't know of any kind of a stipulation for visibility in the IBC. Then the elevator inspector shows up and says, yeah, you thought you were good? Well, you're not good. You've never talked to the elevator inspector. You don't know him. You've never met him. You've never walked a building with him. And he's going to show up 2 days before CO all the time. So it's like the ultimate gotcha if you don't do that. Be careful of this. You have to have visibility in any door of any type if it's immediately in front of an elevator. One other thing you have to have, the whole purpose of putting this door there is that it has to provide an S label for the elevator door that has no S label. So we mentioned this earlier, but this is going back to testing without an artificial bottom seal. Artificial bottom seals can be either, it can be used for testing, but not if that is used in front of an elevator. So a side hinge door, a slab door like this one, almost certainly was not tested without an artificial bottom seal. So they would have had to have duct taped the bottom of that door in order to test it to be awarded an S label. You can't do that in front of an elevator. So really what you're limited to in front of elevators are anything that does have an artificial bottom seal, does have visibility through it, does permit egress through it. And going back to the elevator code, the other stipulation that we learned a moment ago is that generally, or not generally, universally, elevators are transitioned into phase 1 emergency recall because of the smoke detector immediately associated with the elevator. In this case, this door is held open on magnets. I promise you that's not what happens here. That'll open on, that will release on general alarm. All of a sudden, we'll have a door closed in front of an elevator that is normally operating. In most buildings, that won't make too much difference. But in a building like a hospital where you may have to relocate patients and the staff may choose to use those elevators, now we've got a problem. We've got one more obstruction, one more thing slowing them down. What's wrong with this side hinge door in front of the elevator? This is nothing to do with hospitals. This is just a fun thing. Look at that. I'm going to only give you about 5 seconds to figure it out, but there is something in that that would prohibit this from functioning properly. Hopefully you've seen it, and it is not the artificial bottom seal. Let's talk about pathogens for a moment. This is a critical topic, no pun intended. There are 4 pathogens that are of principal concern in hospitals. And this is anywhere, it has nothing to do with elevators necessarily, but these can be propagated throughout the hospital through the elevator shaft. Now, I will tell you that things like Legionella and tuberculosis that we thought was kind of like something we heard about 75 years ago, they are still there. And I had a construction project under scrutiny by the infection control nurse because we had to open up existing walls and expose the insides of the walls. And she said, you're going to be testing the air all the time in this because I'm concerned about Legionella. So this stuff is real and it is there. If you use what we're going to talk about being our next option for solving smoke control that is generally permitted in the code, but somewhat restrictive in hospitals, let's talk about elevator shaft pressurization. So keep those pathogens in mind. And all that stuff is in enclosed spaces. And I promise you that at the very least, Legionella is in that elevator shaft. So when they pressurize that elevator shaft, that's going to push all those little creepy crawlies out into the hallway. That's permitted in general because there's not an infection control scrutinizing the decisions of the IBC. But in hospitals, there are several states that are going to look at that and say, no, you're not going to do that in our hospital. So the state of California and the state of Texas both prohibit this for different reasons, but the effect is the same. State of California is just prohibited in the code, and the state of Texas is prohibited in hospitals in particular because of their administrative codes. So you can't do this in either of the 2 of the 3 biggest states in the country. 2 biggest states in the country, I think. So be cautious about this. And I would invite you to think about this in other hospitals elsewhere in the country as well. Do you really want to do this? Let's look at another reason why you may not want to. We have positive pressure rooms down the hall, somewhere down in another department, but somewhere around there. We have positive pressure rooms. If you pressurize the elevator shaft, The purpose being and the effect of it being that you're going to flow air out of the elevator shaft, which is the whole idea of pressurizing the elevator shaft. You've diminished the difference between the positive pressure room and the hallway by pressurizing now to some degree greater than zero the corridor right in front of you. That has diminished the differential in pressure between the positive pressure room and the corridor. To what degree? You have to talk to a mechanical engineer about that. Is it to a critical point? I can't say. But you have diminished that, and that is now something we need to look at. So there are a lot of pitfalls with regard to elevator shaft pressurization, particularly in hospitals. And then there's the universal issue with elevator shaft pressurization anywhere, in that it has to be tested while demonstrating that the elevator doors can function properly. And there's a maximum and a minimum pressure window within which it has to operate. And sometimes buildings can't pass that test. This one couldn't pass that test. They had to relocate classes. Not a hospital, but they had to relocate classes for the fall semester out of this building. So let's talk about the new section in the 2024 elevator code. Now, I mentioned that the best types of additional doors were once additional doors, another one of the forest of many things that we had in additional doors. Additional doors now are really just side hinge doors, but now we've taken the two most successful solutions for that, pulled them out into their own section called smoke protective curtain assemblies. Now, if you look at this, what does that mean? It looks like an additional door. This is the exact same plan that we looked at for additional doors a while ago, because it does exactly the same thing. It gives you an S label right in front of the elevator doors. So how is this better than a side hinge door? Well, this is an example of one of the two ways in which this is accomplished. So this is a magnetic type system that deploys from the ceiling above and rolls down on either the elevator jambs or auxiliary rails, as the case may be. What does this have to do? It has to provide an S label. Well, it's tested under UL 1784. Has to be tested without an artificial bottom seal. They are. Has to have visibility through it. It does. And has to be able to egress through it. You can. The magnets will release with less than 30 pounds pressure. So you can egress right through this thing. So you have no problems with moving around this building with these employed in front of it. Now, what about, remember we said we could do elevator lobbies. Well, we basically have an elevator lobby with no space in. So in terms of egress paths, the problem that we saw a moment ago in that series of photographs, we don't have that here. We don't have to worry about it. So this is a successful solution. This is now smoke protected curtain assemblies. It was an additional door. And this is a change in the 2024 IBC. Well, there's another type also. Now, this other type has a little bit of a storied history. This is an example of magnetic systems being installed. Can't really see them, but they're there. The other type is a track-based system. There were some pretty bad variants of this in the marketplace years ago. Today, probably in the last 5 years or so, these have made enormous strides, and these are now good solutions as well. Didn't used to be, but they are now. The difference is that instead of a clear film rolling down on magnets, a curtain deploys within these side guides. Now, this is a particularly ugly one, but I'm using this because you can see the components, so you can see the parts and pieces. So these can be more elegantly installed for sure. But the curtain will slide down within that track system. Has to do the same thing, has to have visibility through it, has to have a means of egress out of it. And ideally, both these and the magnetic gasketing systems are deployed by the local smoke detectors. There's not a requirement to do that, but in order to maintain compliance, particularly in a hospital, and coordination with the elevator, it's highly advisable. Fire service access elevator lobbies. These show up in buildings over 120 feet. We'll keep this fairly brief because we don't have all that many hospitals that go that high. We do have them, of course. But there are some requirements. We'll cut to the chase on this. But if you have a building that connects occupied levels in which the elevator has to travel 120 feet or more to do so, then you'll need fire service access elevator lobbies. What does that mean? Well, the interior exit stairway has to be directly accessible from the lobby, and separately has to be directly accessible from the corridor. So you have a little staging area inside there where the firefighters can work. The separation point between that fire service access elevator lobby and the corridor is required to be a 45-minute smoke-rated door. This lobby is enclosed with smoke barriers. This is the only opening in a smoke barrier that I'm aware of in the IBC that requires a 45-minute opening protective, first of all. Normally, they require 20 minutes. This also requires UL 1784 testing without an artificial bottom seal. Again, there's that artificial bottom seal. It is, again, associated with elevators, although not immediately in front of it. You need to watch out for this because the system has to be tested without that bottom seal, which takes slab doors out of the equation. So what do you use? Well, there are overhead fabric curtain systems that will do this. There are integrated hardware doors that will do this, but regular slab doors will not. So what about egress out of here? Well, what egress out of there do you need? If you're a building occupant in that lobby, you're going to go right into the interior exit stair and get out of the building. If you're in the corridor, you're going to go directly into the interior exit stairway and out of the building. If you're a firefighter, you're not going to use that door either because you're fighting a fire a floor above and you're going through the stair to do so. So it's not an issue with respect to that. Okay, we're going to transition to a different type of vertical opening. We talked about vertical openings in hospitals, and we're primarily going to be looking at shafts, which we have, and atriums. So atriums are a common thing in hospitals, but hospitals impose a great many additional requirements on them. Take note that in the 2021 IBC, the definition of atriums changed. It does not affect hospitals, but it may affect other spaces in I2 occupancies. A two-story space, a two-story vertical opening is an atrium. And that's true also in I3s, which are jails. If you get into a business occupancy, a two-story vertical opening is no longer an atrium. But strictly speaking, on just hospitals, it is still an atrium. So the code used to say that, and if you have a two-story atrium, you don't have to have smoke control unless it's an I2 occupancy, which we have here, and that's what we're talking about. Now the definition has really been simplified, that in all atriums are required to have a smoke control system, and two-story atriums or two-story spaces are atriums in I2 occupancies. So just be careful of that, not so much in hospitals, but in other spaces. So let's look at a generic atrium. We're going to be using these diagrammatic building sections to describe this. The first thing you see in section 404, the first place I look is section 404.6. We have to read the whole section, make sure we comply with everything, but a lot of it is very simple, elemental things. 404.6 and then going the other direction, 404.5 are the two key subsections you need to look at. So let's tackle enclosure first. If we have this three-story atrium in this hospital, it is an atrium, and the first thing it says for enclosure is you have to separate it from adjacent spaces with a 1 hour fire barrier. Well, okay, great, except that doesn't make my atrium so much of an atrium, does it? Because remember, fire barriers are limited to only 25% of that wall being available for openings. So you pinch down your openings in there to 25% of that overall wall, or those overall walls, not really allowing occupants of the building to experience the atrium as they otherwise might. Read the exceptions, because the exceptions is where the gold is in the IBC. Exception number 1 says that you can substitute for those fire barriers a sprinkler protected glass system forming a smoke partition. Now they say forming a smoke partition, and they use the term smoke partition. They even italicize the word smoke partition, or the words. When they do that, they're referring to specifically smoke partition as they have defined it. So we can use other smoke partitions and openings within smoke partitions. We can use fabric curtains to do that. And remember, the size of it is not limited. So an opening in a smoke partition, if you have an 80-foot smoke partition, you can put a 79-foot opening in that. You can put an 80-foot opening in that. There's no limit to what the size of that is. So we could enclose, although the first charging language in this section says you have to enclose this with fire barriers, exception number 1 lets you enclose it with something forming a smoke partition, in this prescriptive solution being sprinkler protected glass. Well, that's good. Keep reading because it gets better. Exception 5 lets you leave 3 floors of the atrium open, unenclosed, completely unenclosed. Now, this is boilerplate language. This applies to all occupancy types. We're looking at this through the lens of ITU occupancy. So there is other stuff we have to do here. So this, in a generic sense, works. You can keep this completely unenclosed. Again, we have not addressed smoke control yet. We are only talking enclosure. But in hospitals, we have to separate all of our spaces, nearly all of our spaces, with smoke compartments. So here's the question I would pose to you. Scratch your head about this, come up with your answer on your own, and see what you think about this. That walkway that's exposed to the atrium space, can you do that in a hospital? Well, for the most part, all spaces of the hospital have to be in one smoke compartment or another. In this case, we failed to include it in any smoke compartment, or technically it's connected to the 1A smoke compartment below. There's no separation, and you can't have multi-story smoke compartments. They're inherently separated by floor. So what do you do in a situation like this? Well, you could do something like this. Now, what is the requirement for separating smoke compartments? Right there on top of this slide. Smoke barriers are required to separate smoke compartments. Let's go back to one of the first slides we looked at. What is a smoke barrier? Smoke barrier is a type of wall that can look just like a fire barrier or a fire partition. They look the same. 1 hour smoke barrier, which is the maximum smoke barrier, just a layer of 5/8 inch Type-X gypsum board on either side of a metal stud wall. That's easy. But the trick is in the openings. So this is much more lenient than a fire barrier is, but we have to have smoke rated openings in it. And what is the requirement for an opening in a smoke barrier? 20-minute fire rated opening, 20-minute UL10B or UL10C. UL10B is for overhead systems, and UL10C is for side hinge doors, and a smoke rating. So what would you do in this case? Well, you can drop fire rated fabric curtains around there, so long as they comply with the requirements for a 20-minute UL10B listing and a UL1784 smoke rating. Has to have both. But you can do this with fabric curtains to separate that out and be in compliance with the requirements for both an atrium and smoke compartments. But on the atrium side, we've only complied with the enclosure part. We haven't tackled the smoke control part yet. So let's take a look at that. What do we have to do? So we have one thing left that we have to take care of. Section 404.5 talks about smoke control. Has to be installed in accordance with section 909. Okay. 909 gets into the details of it. 404 tells you what you have to do. 909 tells you how you have to do it. So we have our otherwise compliant, in terms of enclosure, atrium, not in a hospital yet because we haven't separated for smoke compartments. So we have 2 steps we have to take now. But let's look at smoke control. Smoke control normally would just be this. You can just evacuate the smoke. You do not have to have a mechanical solution for smoke control. However, historically, this is what we've seen most often. We have an exhaust fan that pulls the smoke out. We have to have makeup air that lets air in, and we have to keep the smoke level from getting down to within 6 feet of any walking surface required for egress. So very, very generically, we can do this. We can also do passive solutions, but this is a mechanical solution or an active solution. So this is fine in any other building, but is not fine in a hospital because we still have the requirement for smoke compartments. So to take care of that requirement for smoke compartments, we have to separate with smoke barriers those floors from one another. So we've accomplished this. Now sit back and ask yourself, why are we providing a mechanical smoke evacuation system in this atrium? This is a 3-story atrium, and we are providing a smoke evacuation system in an environment in which smoke can't get from floor to floor anyway, because we already have separation for smoke compartments. So passive solution in this example is this. You already, by virtue of having provided the separation between smoke compartments, you have already now provided a passive solution for your smoke control system. So we've already done the work. Now this has done all the things we need to do. It's complied with the enclosure requirement, which is nothing. It's complied with the requirement for smoke compartment separation, which is smoke barriers. And it's also provided a passive solution for the atrium. We have no atmospheric connection between any floor. So this is a satisfactory atrium in a hospital. So let's look at section 909. There's an exception in not 909, excuse me. Let's look at section 404.5 again in greater depth. An exception was added in the 2021 building code, still there in the 2024 building code, that you can omit smoke control entirely if you provide separation of all the stories above the bottom two as you would for a shaft. We talked about this briefly, but how do you protect the shaft? With fire barriers. So if you construct this with fire barriers, you can omit smoke control altogether. But what else do you have to do in a hospital? You still need smoke compartments. So you've actually, in a hospital, made things more complex by selecting this option, because now you have to put a fire barrier enclosure around the top floor, but the fire barrier is not smoke rated. So now, in order to provide protection and separation of smoke compartments, you have to provide smoke barriers at all floors. Now, we're just adding it at the second floor. But at the third floor, we had fire barriers, which are not smoke rated. Additionally, those walls had to perform as smoke barriers. So now, because of multiple use fire assemblies, you have the most restrictive of all of these things all piled up on top of each other. So the opening is limited to 25% because that wall is a fire barrier. And that opening, if it was only in a fire barrier, would not have to have a smoke rating. Well, now it's also in a smoke compartment, so you do have to have a smoke rating because it has to comply with the requirements for a smoke barrier as well. Again, this takes us back to multiple use fire assemblies. So that is the very restrictive way to go about this. So needless to say, we don't see this done in hospitals. We almost never see this done anyway, but this makes everything more complicated by exercising that exception. Let's talk about a couple things in NFPA 101 because we have to pay attention to that for obvious reasons. You can do atriums in a hospital, but there's some stipulations to that. Generally speaking, as we look at the requirements of NFPA 101 and we look at the requirements of the IBC, we're going to have to comply with both. We can't say, well, I'm going to choose the NFPA 101 way because that's easier. Well, no, you still have to comply with the building code. We still need a building permit, and that's going to require a sign off on from the building department. And those are the HJs enforcing the IBC typically. But we also have NFPA 101 that we have to provide too, because that's enforced by CMS via the Joint Commission. So we can do things with atriums, but this does not mean, even if it's more lenient, which is not necessarily, it's pretty parallel, we still are required to provide by the more restrictive, provided that covers both. Let's look at atrium entries as an example. And in that hospital that we looked at where I had omitted smoke protection at the ground floor incorrectly, we had a situation like this there also, but many hospitals have this. You'll have a two-story space near the entry. What do you do in a space like this? It doesn't have to be near the entry either, it can be anywhere. So we know that we have smoke compartments. We know that we have to separate this with construction equivalent or satisfactory with the definition of a smoke barrier. But we also have to provide smoke separation. We have to provide, our openings are unlimited. So that opening has to be 20-minute UL10B or UL10C. What do you do in a situation like this? Well, that's what you have to do in this case. You have to have a smoke barrier separation. Now, in a hospital, this is an atrium. And in a hospital, a two-story atrium is required to have a means of smoke control. But we have already provided the passive solution for that by virtue of having complete separation floor to floor. So in a certain sense, the fact that things are a little bit more restrictive in hospitals actually solves other problems that we otherwise would have to come up with a new solution for.
This concludes our AIA Continuing Education On-Demand presentation. On behalf of SmokeGuard and the EBS Group, thank you for your time and attention. As a reminder, you'll need to complete a 10-question test to receive credit for this course. Simply click the test button below to get started. After completing and passing the test, you will receive your AIA Certificate of Completion by email to the address you provided before taking the test. If you're an AIA member and you provided your member number, we'll submit your credit directly to AIA on your behalf. Please allow up to 10 business days for your credit to appear on your AIA transcript. To recap, SmokeGuard's core offerings include standard and custom elevator smoke containment solutions and vertical, horizontal, and perimeter fire and smoke curtains. If you would like information on any of our products, design support, or additional AIA presentations, you can contact our support team or visit our website. Additionally, The EBS Group offers AIA-approved courses on life safety products. Balco covers expansion joints, photoluminescent egress systems, and fire stopping. SmokeGuard focuses on fire and smoke protection solutions, and Greco offers courses on commercial architectural railings and code compliance. Scan the QR codes or visit their websites to explore all available courses. If you have any questions or would like more information on SmokeGuard, visit our website at www.smokeguard.com. Thank you again for your time and interest. We look forward to seeing you on our next AIA On Demand video presentation.